Hello, my friends. Good night. Welcome to my channel, the Narcos Networking channel. My name is Luis Narciso. I'm a network and security engineer working towards a challenge, and I say, or should I say, a quest regarding the BGP protocol. I have set this goal to myself. I've set this goal to talk about the BGP protocol for 100 days. And today it's my 94th day, so I'm almost at the end. And for today, we are going to troubleshoot the problem that we faced before the end of the last video, which was the extreme switch not being able to ping the FortiGate's firewall loopback address. So from its loopback 1.1.1. So the traffic was going towards the MikroTik, and from the MikroTik to the loopback address. But we didn't have success. So let's try to figure out what can be wrong in here. From my understanding, we have some misconfigurations regarding the IBGP process that is established between the MikroTik and the FortiGate. So let's begin and let's address this issue. So for that, before we start, I will place in here the name of the VLAN that is configured on the extreme switch. Okay, so that our design can be more intuitive. And now let's go to the MikroTik and set up the next top self on the processes because I believe it is required to solve the reachability issues where the internal routers cannot find a route to the external EBGP next hop IP addresses. So let's go to MOBA and insert the super user password. Now we are going to the routing BGP connections, and we should have here two connections, and we are going to manipulate this one, the one that is going towards the FortiGate. So we are going to set this connection, and we are going to force next to self choice equals force self. Enter. Now if we do another export to see what is configured, and we have it here. Okay, done on the MikroTik side. Now we need to do the same on the firewall side, on the neighbor to that is configured, that is the BGP, the MikroTik. So admin, super user password, amazing. Now config router BGP config neighbor, and let's edit the MikroTik 124 42 24. Let's see what do we have here. Oh, I have it enabled already. Uh, one step ahead. So to enable it, we need to place the command set next of self enabled. And now we do next and show to see what we have. Okay, it's done. And let's see what we have on the BGP process. Okay, we have the neighbor MikroTik that is to the MikroTik that is configured with the next of self, and we have the neighbor extreme that is on this side. Okay, so in this case, the traffic coming from the AS 65001 from the link that connects the extreme to the MikroTik and going towards the IBGP process, we'll have the next hop as the MikroTik. For the traffic that is coming from the AS 65001 from the link that connects the extreme to the FortiGate and going towards the IBGP process, we'll have the next hop at as the FortiGate. So this is what we achieve with these configurations. So besides this, the MikroTik should redistribute the routes learned via external BGP. So the routes that the MikroTik will learn from this process that is established between the AS 65001 and the AS 65000, he should propagate the routes because um, the FortiGate will not know how to go back to the 1.1.1.1 via the IBGP process if it doesn't redistribute them. And for that, we are going to manipulate once again the process. Uh, and let's do it. Add, it's not that, it's set MikroTik to FortiGate, and we are going to set these values in here. The output.redistribute connected static, and we are going to add BGP. If we do again an export, it's here, connected static and BGP. So after this, if we take a look at the routing table from the Extreme switch, we will visualize that the route that is being installed on the FIB to the FortiGate's loopback is the route that is going towards the MikroTik via eBGP. Because let's see it. I will explain it later. Let's go to the Extreme admin super user password, and now with the command show IP route, what do we have here? We have two routes to the 4.4.4.4. Okay, one via BGP external towards the gateway 121.12.21, that is the MikroTik, and this is the one that is installed on the FIB because we have here an F, and the F stands for, let's search for it, FFF. Where is the F? F, where are you? Right here. Okay, flag F provided to the FIB, which means that the second route that is going towards the FortiGate, it's on the routing table, but it's not used. The one that is used is the one that goes to the MikroTik. This is because of the selection of the criteria of the BGP process. Because the full order of operations is, first of all, if we are talking about Cisco, the highest weight. Then we are going towards the highest local preference. Then the locally originated. Then the shortest AS path. After that, the lowest origin type, the lowest MED, that stands for multi-exit discriminator, the eBGP paths over IBGP paths, the lowest IGP metric to the BGP next hop, the oldest path for eBGP, then the lowest router at ID, and at the end, the lowest next hop IP. And for us, the lowest next hop IP, it's the one that is going towards the MikroTik. Okay, and in order to solve this, we can try to see if the routes are being received on the firewall. But for that, we need to configure the neighbors with the command set soft reconfiguration enabled, and then we need to clear the BGP process. So let's do it. So let's config router BGP, config neighbor, edit the 124.42.24, and let's insert the command set soft reconfiguration enable. Okay, done. Now let's place next, and let's edit the other, that is the neighbor extreme, and let's set the same command, set soft reconfiguration enable, next, and end. So let's clear the process, execute router, clear BGP 124.42.24 soft, execute clear, execute router clear BGP. I missed the IP. And now we need the soft. Done. And now we need to do the same for the extreme. And it's done. So now we can execute the command that allows us to visualize the received routes. And to visualize the received routes from the MikroTik, we go and set get router info routing table. Nope, sorry. Router info BGP neighbor, the MikroTik neighbor, and received routes. Boom, here we have a received route from the MikroTik that is coming from the interior gateway protocol, that is the BGP, the IBGP, and we have the next hop 124.42.24. So let's see what are we receiving from the extreme. And from the extreme, we are also receiving a route to 1.1.1.1 that is going um, towards the extreme. Um, And what can we understand from this? As it does not have an E, it is coming from an exterior gateway, exterior BGP. And regarding this, the metric would be lower. For external BGP, the metric is 20, and for internal BGP, the metric is 200. So, in order to see what is the route that is installed on the FIB, we use the command get router info routing table all, and here we can see that we have a route to 1.1.1.1 via the extreme, and as we have seen, 20 stands for exterior. So what is our problem? Our problem is that when we try to ping from the loopback 1.1.1, the loopback 4.4.4, we are going towards the MikroTik. Then the MikroTik then sends the traffic to the FortiGate. The FortiGate receives it on port 1 and sends to loopback 4. Until here, everything is okay. But what happens next? Next, the FortiGate will try to send the echo reply to the echo requests via port 2 and send it back to port 1 to arrive to loopback 1.1.1.1. But this stands here, presents here a problem that is called asymmetric routing. And the FortiGate has something called RPF check. And the RPF check, when this happens, will drop the traffic. So what are we going to do now? If we run a continuous ping from the extreme switch loopback address 1.1.1.1 to the FortiGate's loopback 4.4.4.4, let's see what happens. Ping from VR default, continuous. Let's ping the IP 4.4.4.4 from 1.1.1.1, and we are not getting success. Um, it is giving us request timeout because of what I have explained, the reverse path forwarding, also called RPF check. And we can verify this by running the following command on the firewall. Let's go again to the firewall. So let's diagnose sniffer packet from any interface, the protocol ICMP that are the pings, um, and for the host 1.1.1.1. And let's say that the verbosity will be 4 to print the header of the packets with the interface name. And let's see what happens. What are we seeing here? We are seeing that traffic is arriving on port 1, as I told you, from the IP 1.1.1.1 and going towards the loopback address 4.4.4.4. But as you can see, we only have echo requests. We don't have the echo replies because the firewall is dropping them. So in order to solve this, and to see that is really a symmetric routing, um, what can we do? We can uh, enable the firewall to allow the asymmetric routing. Um, let's do it. Config system. Let's move this here so that you can see that the pings will start working. Config system settings. And now we are going to set the asymmetric route enabled. And now when we press end, you will look at your right side here and you will see that the pings will start working. Boom, nice to see. Now let's run the command on the firewall again to see what happens with the diagnose differ packet any ICMP and host 1.1.1.1 with verbosity 4. And now we can see that we have the traffic coming in port 1 from 1.1.1.1 to port 4 to port 4 not to loopback 4 4.4.4.4 and it is being replied out of port 2 out of this port here from the IP 4.4.4.4 and going towards the loopback address on the extreme switch. But from my understanding, and please correct me if I'm wrong because I don't know everything. This is not the best practice that we should have in production or in any network. So this should be this is not the ideal way of work. For me, the ideal way of work is the traffic arrives from one side and goes back from the same side because this can lead to man-in-the-middle attacks, for example. Uh, it can be an assumption because if someone is sniffing the traffic and sending it to another port manipulated, and the firewall accepts it, this is not a good practice. So let's disable this on the firewall and let's try to see if we can arrange an alternative to this problem. Let's unset the asymmetric route and now the traffic should give requests timeout again, and it is giving us requests timeout. So we have checked that this is a problem. And how can we fix this? We can try to manipulate the local preference on the extreme, for example, so that it can choose. Let me share again. So the traffic at this point in time is going from loopback 1 towards the MikroTik and coming here, and after being here it is dropped. So what we need to do is on the BGP process, instead of it choose the path via port 2, we can make it choose the path via port 1 because it is choosing port 2 because of the IP address being on a lower IP because of the /27 um, and it has the local preference of 100. So here we have also 100, but if we do the local preference here to 200, this path should be preferred, and this path is being installed on the fib, sorry, and it is going back. So let's try it. So for this, to manipulate these, um, we need to see the local preference here on the extreme. If we place the command show BGP routes for network 4.4.4.4/32, what do we have here? We have here that we have the best preferred path via the 121.12.10WN, okay? And we have the local preference of 100. But we have another path. It is the MDM stands for multipath, uh, and it is via the 100.14.41.41. Okay, but if we say show IP route, we can see once again that the path chosen and installed on the fib is the path towards the MikroTik, and we don't want this. So to change this, we need to create a policy on the extreme switch and map this policy to the neighbor. So let's start it. On the extreme switch, we have the text editor, the V, and we are going to use it. Edit policy. And now we are going to name the policy. Let's say set local preference, oh no, local pref 200 dot policy. Okay, now we are inside the text editor. We are going to press Shift I to enter text mode, and we are going to set our script. So for the entry, set local underscore pref. What is going to happen? 1, 2, 3, 4. This should be well indented. If match all. 1, 2, 3, 4, 5, 6, 7, 8. Network layer reachability information. Let's say 4.4.4.4/32. 1, 2, 3, 4. Oops. 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6, 7, 8. Then what we are going to say that the local preference is 200. And 1, 2, 3, 4. Let's close our curly brackets. Oh, sorry, I forgot something. 1, 2, 3, 4. 1, 2, 3, 4. And we need to set the action. We need to permit. Now we are going to close the curly brackets, and we are going to close the curly brackets once again. Now we are going to save it. Escape, right quit. Now we need to check if the policy is okay. And for that, I believe that the command is check policy and the name of the policy. Yes. So the name that we gave to our policy was set policy 200, and the policy file check was successful, which means that I have not mistyped anything on the policy. It is working. But now we need to insert it on the BGP process for the FortiGate neighbor. So for that we are going to configure BGP neighbor. And we are going to say that the neighbor is the 100, 14, 41, 41. And we are saying that we are going to map to it the route policy. And the route policy is going to be in what is going in, okay, and the name of the policy. Okay, set local pref 200. Boom, done. Let's show configuration BGP, and we have it here. Okay, now we need to refresh the policy so that it can be configured and read by the system. So we are going to refresh policy set local preference 200. Done. Okay, policy refresh done. Now let's see again the routes to the network 4.4.4.4. Show BGP routes network 4.4.4.4 slash 32. And what we have here, that we have a local preference of 200, and it's towards our FortiGate. Done. Amazing. If we see show IP route, now the flag should be on the other side. Now we only have it here, okay, and it's towards the FortiGate. Nice, very nice. It was what we would like to have. So let's try to ping again. Ping vr vr dash default continues the 4.4.4.4 from 1.1.1.1, and haha, success. Let's put now a sniffer running on the FortiGate again. Diagnose sniffer bucket any ICMP and host 1.1.1.1. Oh, I forgot the verbosity. And we are having the traffic coming from port 2 in and going out from the same way, port 4. Port 2 from the IP 4.4.4.4. So it is working as we pretend. It is nice to see this working. So now what can we test here? We can test if the routing table converges. If for example, if we lose the link between the extreme and the FortiGate. So for that, I am going to disable port 2 on the FortiGate. I am going to put this port in a shutdown state. Okay, and let's see if the traffic reconverges and we can have traffic uh, flowing from the extreme to the MikroTik and to the FortiGate, and then going back to the FortiGate to the extreme. Let's see, config system interface, edit port 2, set status. I believe it's down. Okay, next. Now you are going to lose the pings from the extreme to the FortiGate, and I believe this will take more or less 3 minutes to reconverge. While it reconverges, we can go to the routing table of the firewall and see if we have a route towards the extreme via the IBGP process. Get router info, routing table all, and as we can see, we have a route, and the route is via the IBGP process. So this is taking a while to reconverge because we are not only talking about the process between the FortiGate and the MikroTik, but we are also talking about the process between the MikroTik and the Extreme. Uh, so what can we test more while this happens? We can try to execute a ping from the FortiGate with the options source 4.4.4.4. Okay, and now we can execute a ping towards 1.1.1.1, and what happens here? Nothing. We will not have success. Okay, 100% packet loss. So execute ping options reset, execute ping 1.1.1.1, and we can reach it, and we reach it via the MikroTik IP. So let's see what do we have here on the routing table. Oops, it was working. Haha, it has converged. So as you can see, our traffic is working. Our BGP process has reconverged. We now have a topology that is resilient. It takes 3 minutes. It's a while. It's in the IT world, 3 minutes. It's like the end of the world for the end users. But we have success and we have reached our goal for today. So let's take a look again at the routing table, and let's place the interface again in an upstate and see how long would it take to reconverge. I believe that it will take less time because the connection between the BGP process is direct. It's eBGP with one hop. So let's see what happens here with the pings. It's not settings. Config system interface. Edit port 2. Set status up. End. Now let's take a look again at the routing table. Oh, we lost a ping. I believe that was because of the reconversions. Let's see. Yes, it is. We have the administrative distance of 20 and towards the extreme. Nice, amazing. So that's all for today, my friends. I hope that you have enjoyed this session. Thank you for your time watching me explaining these configurations. I hope it is useful for you and for your day-to-day basis. So, see you soon. Thank you very much once again.